Hi, today's for just another blog article. You can find it on my homepage. And in this case, it is really about schema drift, when historical and current versions of the data set really should be two different data sets rather than one. I've covered a version of this before, but basically the idea is when we put data in a data lake or in a reporting repository, some analytical store, are there cases where that data really is so different, at least in the raw representation, in the producer-driven schema, that we should make them different data sets? And I'm going to do a couple versions around that and why that could be. So our general policy for versioning here and for trying to figure out whether things should be in the same data sets, we're going to start off by saying that we need to version all the data sets and the schema changes. And so we want to capture that in a catalog somewhere, register it. And then we're going to go with kind of the standard model for what major and minor versions are. Minor versions are versions that are backward compatible. So column, table, property additions, graph element additions, those are all fine because they don't break the existing consumers. So for the purposes of this, minor versions are ones that don't break existing consumers, but add new features if the consumers want to pick them up. And then the major version represents a breaking change from the previous version. So if you were using the previous version and you were to point at a data model of the new one, you'd actually be broken. Those could be complete table change, or, entity changes. They could be a lot of things. Cardinality, data type changes. And then I'm going to argue here, as I have in the past, that data should be stored in separate raw zone data sets based on breaking changes. And the other option is you store these in the same place. And I've seen most places do this. And what ends up happening, you have to know all the magic dates. In July 1990, the data changed to this, and you got to know that and write special code. And then in 2001, we did this, and in 2022, we did that. Well, that'll be good for the video next year. And then some schema catalogs, we're going to use a schema catalog for this, and some of them only support schema migration for non-breaking changes. So if you were to do like a system migration and went from a 1.0 version to a 2.0 version, in those cases, you may have to register this as a new data set. You just got to look at your data catalog, and understand whether it makes sense to have breaking changes in the same data set. I'm going to argue in this case, well, you know what? It just depends on how you want to do it. And then consumer-driven models can be aggregates of producer schema versions. So if I had a 1.0 version and a 2.0 version of the data, then my conform tier or my analytical tier could actually be aggregated, and they might go through some transforms to make those two data sets look similar enough, or we might keep them separate, and we'll discuss a little bit about that as we go on into this. So I'm going to start with this model here, and the diagram isn't perfect, but it's amazing still. So in this case, we're going to talk about a source that has two 1.0 versions, and then we bought a new system, we replaced the existing system, and we have a 2.0, and everything from that date forward is in a completely different format, or format that's different enough that it would break queries and that kind of thing when we converted it to conformed. So in this case, I'm going to argue that what we should do is we should create two different raw data sets, and we can combine these in the conformed tier later. And so in red, we have the V1 and V11 and however many arbitrary versions there are for that in that data set. And then we have the V2 version, which is the new platform that we're on. And so then they'll have 2.0 and 2.1. Now, some of the same data may be in both, from version 1, maybe in version 2, and that's because we may have converted that data from version 1 into version 2. So version 2 may actually hold an aggregate if we populated it with historical data, and I'll talk a little bit about that later. So if we were to decide what we're going to do in the conform zone, so basically we have a raw zone, which is just completely producer-based, could just be a giant JSON blob. And then we have the conform zone, which is really the first place like if we were in an analytical store, first place we have tables. It might be some other kind of processing that makes it usable by consumers. The first place that it's relatively straightforward to consume with standard tools. So I'm going to there's two versions of conformed here. And one of them is we just, we kind of break conformed, right? Maybe we do. And what we do is we just do 1.0, 1.1, and then we change it to 2.0. And we figure out some way to make that happen. And what ends up happening is the consumers that are sitting on that schema on the top actually end up breaking when we move to 2.0. And so the downside of this approach is everybody's got to move on a big bang date, right? Because their queries just break. It's not like they won't return date, just return old data, but they'll break completely potentially. But this is still the way a lot of places do this. They just change it, and then everybody's got to realize it, and they try and communicate that. It depends whether you know who all your consumers are, and there's other advantages and disadvantages. I'm sure people will send me email like they usually do. Sad face. Now, in the version 2, we did something a little different, and I did the colors wrong here, and I apologize. So basically, the bottom track is the 1011, and what we could do is we would just stop producing in that conform zone, kind of like we did in the raw zone when we reach 1.1 and we create a new conformed table. And in this case, because we migrated the backfill data into that data set, we would actually have the original data, but it would be in the new format. And notice, in this case, I decided to make it the 1.1 version, but it could be 2.0, it could be anything. Each individual data set has its own version sequence, and then we tie those together in the catalog somehow. And so in that case, we could either make this the 2.0, where it's 2.0 on the line above, or we could make it 1.2. A lot of places will just start 1.0 with every data set, and then they'll use Lineage to bind together version 2 of this model against version 1.7 of this model. And so in this case, on the bottom, none of the original consumers will break, but they will stop getting data when we quit filling the original conform zone. And in the middle line, that would be, everybody would migrate to that. That would have some of the backfilled data. If we needed it, we might decide really old data we didn't want, so we might walk away from some of the data. That's why it's 1.1. Maybe we walked away from the 1.0 version. And then we would just keep building that conformed from the raw zone. And so those are like two different ways you can do conformed across breaking changes that come out of raw zone change. Producer model changes that got fed to a raw zone that get fed to conform. So the last area, why didn't that pick up? Sorry. So the last area, you know what? Let's do this. Let's see if we reload. What happens? I might. There you go. That's the drawing I wanted. That's what happens when you demo live, or you keep updating it. So in this case, I got 2 lineage patterns here. We could go with either. And so some of this represents versioning. And so in this case, the blue is the source version, the red, and then we got some other stuff here, right? And so on the top line, what we did is we have the original 1011, and in this case, and this is raw. I didn't do any work on conformed. I just put it on the end. So in the raw zone, though, remember in the first one of these, we switch data sets names when we move from the 1.0 to 2.0. That's what the top line lineage looks like. You can see we go from 1.0 and 1.1 on the source. Those go on the original system raw zone, and that got transformed into conform. We'd have some lineage for that. The bottom line of the top diagram, we actually did schema evolution from 1.0 to 2.0. We need to link those somehow, even though they weren't compatible, but because they represent the same data, we'd like that growth. There's other kinds of lineage, which is sort of like the transformations. So in this diagram, I've merged schema evolution and transformation and data transfer between systems. That's probably a mistake, but I wanted to kind of only do one diagram. So here, the source 2.0 is the only source for the replacement raw zone data set, and then somehow those either, or if we decided, depending on what approach we took, eventually those would transform and end up in the conform zone, first one. And then the other, conform might actually be able to do both, right? On the top, we had a set of transforms for the original data, and then we have a set of new transforms for conform for the bottom data. And the original data transforms never need to run once we migrate to 2.0. So the other version of this that I see here on the bottom is one where we had the 1011 in the raw zone, and we went to 2.0. We created a replacement zone just like above, but then we backfilled the 1.0 data into that raw zone. That was the second diagram up above. And in that case, we have a little more complicated lineage, right? Because we did some 1.0, 1.1 transforms into the replacement raw zone, and that would have put it in the 2.0 format, which we'll call 1.1 here. That's not confusing. And then we'll bring in the source 2.0 version and layer that on top of the backfilled data. And you can see that the conform zone at one time had a pointer from the original raw zone, but now it has a pointer from the new raw zone. And so we have that transform. We move that transform. We would have versioned conform and changed the source data set and the transform that was required for that. So that's it. I really just wanted to kind of give a feel for what we might do. Let's see, is there anything else in here? No, some pretty words. And then this really discusses, section discusses what we looked at in this part of the diagram. So that's all I've got. I hope that was useful. This is really about what you would do in raw zones when the producer changes breaking data models, what you can do in Conform, and how you would track that for Lineage. If you have any questions, leave feedback, and I hope you have a great day. Bye.